Hi, my name is Allison Miller, and this is for Math 165, Julie Cantrell. Okay, starting with Chapter 4, the first problem I chose for that was problem number 5. So, problem number 5 states, assume you've applied for 2 scholarships, a merit scholarship, M, and an athletic scholarship, A. The probability that you receive an athletic scholarship is 0.18. The probability of receiving both scholarships is 0.11. And the probability of getting at least one of the scholarships is 0.3. So for part A, it asks, what is the probability that you will receive a merit scholarship? So in the problem, we were given the probability of athletic, of both, and of at least one. So we're not sure of the merit, so what we're going to do is we're going to take 0.3, which is the probability of at least one of the scholarships, and add it to 0.11, which is the probability of getting both scholarships. And that is 0.41. So that'll be the answer for part A, the probability they receive a merit scholarship. For part B, the question asks, are events A and M mutually exclusive? Why or why not? Explain. And for this one, the answer would be no, they are not mutually exclusive because you can receive both scholarships. A mutually exclusive scholarship, as stated in the notes, is defined as 2 events are mutually exclusive if when one event occurs, the other cannot. So for this case, it says we can receive both scholarships because there is a probability of receiving both scholarships. So that's pretty cut and dry with that. For part C, it asks, are the 2 events A and M independent? Explain using the probabilities. For this one, the answer is no again because the probability of A given B does not equal the probability of A. So in our notes, the definition of independent events, it says that the probability of event A is not changed by the existence of event B, and I guess vice versa. So for the 2 events, if 2 events are independent, it means that the probability of A given B equals the probability of A. And then also the probability of B given A equals the probability of B. So for those 2, that is not true, and that's kind of explained in the other 2 examples. For D and E, so they are not independent because, like I stated before, the probability of A given B does not equal the probability of A, and the probability of B given A does not equal the probability of B. For question D, it says, what is the probability of receiving the athletic scholarship given that you have been awarded the merit scholarship? So this is a case of the probability of A given B. So we take 0.11, the probability of both scholarships, divided by 0.41, which is the probability of A, the first scholarship. And that is a formula that we have to figure out. Those are the formulas if you would want to find, which was given on a formula sheet, the probability of A given B, the probability of B given A. So we do 0.11 divided by 0.41, and that's 0.2683. So that would be the answer for part D. And then part E states, what is the probability of receiving the merit scholarship given that you have been awarded the athletic scholarship? So this is kind of the same thing but reversed. So it's the probability of B given A. So again, the same formula, it's the probability of both scholarships divided by the probability of B, the probability of getting scholarship B. So 0.11 divided by 0.18 because that's the athletic scholarship, and that is 0.6111. And that's it for chapter 4, and that's number 5. Okay, so moving on to chapters 5 and 6, this is problem number 2. And the problem says, a local university reports that 15% of their students take their general education courses on a pass-fail basis. Assume that 15 students are registered for a general education course. So part A is, what is the expected number of students who have registered on a pass-fail basis? So from the problem, we already know it's a binomial problem, so that is used on our calculators. And we also know from the first part that 15%, so that's our probability, P, and it says that 15 students are registered, so that'll be our number of students, 15. So this is asking for the expected number, which is also known as the mean. So all you do for that, we use our formula, the mean equals n times p. So just type into your calculator 15 times 0.15, and that is 2.25, and that will be the expected number of students who are registered on a pass-fail basis and the mean. For part B, it says, what is the probability that exactly 5 are registered on a pass-fail basis? So for this part, we already know that the number is 15, the probability is 0.15, so the only thing changing right now is our x, or adding, I guess, and that'll be 5 because it told us exactly 5 students. So we take that information, and as I said before, it's a binomial PDF because it's exactly 5, and you type in your calculator second bars alpha A, and that'll bring up the binomial, and you just type in 15, comma 0.15, comma 5, and that is 0.04490. So that is the probability that exactly 5 are registered on a pass-fail basis. For part C, it says, what is the probability that more than 4 are registered on a pass-fail basis? So our probability is x is greater than 4, not greater than, equal to, just greater than. So as before, n equals 15 is the same, and p equals 0.15, that's the same. So we want the x value to be 5, 6, 7, etc., because it's more than 4. So what we're going to do is we're going to go to second bars alpha b, which is binomial CDF because it's cumulative. So we type in 4 on the calculator because we want to get everything after that. So when we type in 4, we get 15, comma 0.15, comma 4. We get 0.9383. And then since we want greater than 4, we're going to do 1 minus the answer, and that's 0.0617. And that's the probability that more than 4 are registered on a pass-fail basis. And we do that because we don't want 0, 1, 2, 3, 4. We just want from 4 on. And then part D says, what is the probability that less than 2 are registered on a pass-fail basis? So again, our probability is x is less than 2, not less than or equal to 2. So we don't want to include 2 in our answer. Like before, n equals 15, p equals 0.15, and then our x, we want it to be everything less than 2. So just using positive numbers 0 and 1, just for an example. And then we want to type into the calculator the 1. So binomial CDF, second bars alpha b, 15, comma 0.15, comma 1. And that'll be 0.3186 because that means everything up to 1. So that is including everything else because we don't want to include 2 in that. And that's it for question 2, chapters 5 and 6. Okay, and for our final chapter, it's chapter 9, and I chose to do number 17. So first I'll read it, and it states, the mean length of a work week for the population of workers was reported to be 39.2 hours. Suppose that we would like to take a current sample of workers to see whether the mean length of a work week has changed from the previously reported 39.2 hours. So part A states, state the hypotheses that will help us determine whether a change occurred in the mean length of a work week. So first we're going to do the null hypothesis, which is u equals 39.2, and then the next one is the alternative, which would be u does not equal 39.2 because it's asking us to see if it changed, meaning it goes up or down. So we're sticking with the two-tailed equal to or not equal to. So it's pretty black and white, yes or no. For part B, it says, suppose a current sample of 112 workers provided a sample mean of 38.5 hours. Use a population standard deviation equals 4.8 hours. What is the p-value? So for this one, it's a little more complex. So first we're going to state what we know. We know that the mean is 38.5. We know the number sampled is 112. And we know the population standard deviation is 4.8. So with those numbers, we have a formula for the z-value. And it's z equals the mean minus the null hypothesis divided by the standard deviation divided by the square root of the sample population. So that'll be 38.5 minus 39.2 divided by 4.8 divided by the square root of 112. And we get the z-score of negative 1.54. We look that up, and the area is 0.4382. So to get our p-value, we draw the picture, and that will be between 38.5 and 39.2. So we have to subtract 0.5 minus 0.4382, which is 0.0618. Since it is a two-tailed, we're going to have to do 2 times 0.0618, and the final answer of our p-value is 0.1236. So that is the answer to part B. For part C, it says, at A equals 0.05, can the null hypothesis be rejected? What is your conclusion? So for that final part, since that 0.5, what we do for this is we use the formula, the p-value is less than or equal to A, then it is rejected. In this case, our p-value is 0.1236, and that is greater than 0.05, so no, we will not reject the null hypothesis. And that is the end of problem number 17 and chapter 9 and all the other problems. Thank you.